Today we're going to learn about inverse trigonometric functions, angles of elevation and depression. The most important thing you got to remember is an inverse function is used to find an angle. The little -1 you see right here means inverse sine, inverse cosine, inverse tangent. And how it works is, go back to what we learned before, the sine of an angle is a ratio, opposite over hypotenuse. It's some decimal. The cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. Notice we plug in an angle when we use sine, cosine, and tangent. When we use an inverse function, we don't plug in an angle, we plug in a ratio. The inverse sine of whatever decimal that is opposite over hypotenuse will be an angle. And that's the angle that has that sign. The inverse cosine of adjacent over hypotenuse, again, you're plugging in a decimal or fraction. The answer will be an angle, and the cosine of that angle will be that decimal. And the inverse tangent of opposite over adjacent, which is some decimal, will give you the angle. And if I say the tangent of the angle, it will give you that decimal that is opposite over adjacent. For example, I could say the sine of 30 degrees, notice I'm using normal sine. Sine is opposite over hypotenuse. Opposite the 30 is the 1, and the hypotenuse is opposite the right angle, that's 2. The inverse sine of 1/2 would give you 30 degrees. The cosine of 30 degrees is adjacent over hypotenuse. That would be √3 over 2. And the inverse cosine of √3 over 2, that's some decimal, would give you 30 degrees. And lastly, the tangent of 30 degrees, so katoa, it's opposite over adjacent, which would be 1 over √3, which, by the way, we normally rationalize. We multiply by √3 over √3. We don't leave a root in the denominator. This would be 1 √3 or √3 over √9, but the square root of 9 is 3. The tangent of 30 degrees is √3 over 3. And the inverse tangent of √3 over 3, notice I'm not plugging in an angle, I'm plugging in a ratio. That would be 30 degrees. You've got to remember, this is the key to understanding. If you're trying to find an angle, you use the inverse function. Let's find x and y. Those are the degrees we're looking for, those two angles. If I wanted to find x, I see that 3 is the adjacent and 12 is the hypotenuse. And I go to SOHCAHTOA, and I'm looking for adjacent and hypotenuse. And I see that that is cosine. This is going to be an angle we're looking for. That means I'm going to use the inverse function. The difference being here that we don't put in an angle, we put in a ratio. When we use an inverse function, it's a ratio we plug in, or it could be a decimal. In this case, it's adjacent over hypotenuse, which is 3 over 12. And that will give me x. I plug that into Desmos. Make sure you click the little tool icon and choose degrees, not radians. You can get this little -1. It's not actually a power, it means inverse, but if you hit the Shift 6, which is the exponent, and type -1, Desmos understands you mean inverse. Or you can click on the lower left and bring up the keyboard and click functions, and you'll see inverse function there. But we can see here, we'll round to the 10th, it's about 75.5 degrees. If I was going to find y using the 3 and the 12, change colors, I can see that 3 is the opposite of y, 12 is still the hypotenuse. I'm dealing with opposite and hypotenuse, which is sine. We're looking for an angle. That means we're going to use the inverse sign. We're not going to plug in an angle like the normal sign. We're going to put in a ratio. That's 3 over 12. And that will be what y is, y degrees. Y equals, put that in Desmos, rounding to the 10th, that's about 14.5 degrees. Let's point out, too, that we really didn't need to do this to find that angle, because I know that the x plus the y plus the 90 equals 180. I could have gone 180 minus 75.5, and that would have been 14.5. Angles of elevation and depression we use a lot in trigonometry. The angle of elevation is the angle formed between the horizontal, I'm looking at the bottom and the little stick figure, between the horizontal and the distance up you need to see something. Imagine looking straight ahead and the angle formed between that and how far up you have to look to see an object, say in the sky or in the distance. The angle of depression would be, imagine you're the pilot and you have to look down to see this person on the ground. It would be the angle formed between the horizontal and the distance down the pilot has to look to see a person on the ground. Notice that since these horizontals are parallel, if I put the same number of marks on them, they are parallel, that those two angles are alternate interior angles. They are congruent. We can measure these angles with a device called a transit. You've probably seen these devices as you've driven around town. They use them to do surveys and measure angles to be accurate about locations. In this example, you're given the angle of elevation, it's 49 degrees. The angle of elevation is the distance from a horizontal up to the top of an object, or the object you're looking at. It's 49 degrees, and the shadow of the building is 270 feet. How high is the building? First of all, notice we are not looking for an angle. We do not use the inverse function. We need to see, though, that x is the opposite, and 270 is the adjacent, and opposite over adjacent. Remember SOHCAHTOA. Opposite over adjacent is tangent. Since we're not finding an angle, we don't use the inverse. It's going to be the tangent of an angle, 49, equals opposite over adjacent, which is 270. Put that over 1 and cross multiply. X times 1 is x. 270 times the tangent of 49. Go put that in Desmos. Don't forget to switch it to degrees. And we round that to the 10th. It doesn't say here, but normally rounding to the 10th is good. That is 310.6. 310.6 feet. In this example, we're going to find the angle of elevation, the distance from the horizontal up to the top of the object we're looking at. We can see the shadow on the ground is 73 feet, and what we have, y, look at y degrees, we have the opposite over the adjacent. That takes us to SOHCAHTOA. Opposite over adjacent is tangent. Now, what's different about this one is we're looking for an angle. And when you look for an angle, you use the inverse function. That'll be the inverse tangent. We don't put an angle here, we put in the ratio, 22 over 73. And whatever that is will be my y degrees. Put that in the calculator, make sure you're in degrees, and round to the 10th, that's about 16.8 degrees. The rest of this video is questions from your assignment. We'll start with question 3. 1, 2, and 3 are review. They're finding side lengths. When you find side lengths, you use the normal sine, cosine, and tangent. And it'll be the sine, cosine, and tangent of an angle. What we have to do is figure out which one it is. That takes us to SOHCAHTOA. We see that 121 is the adjacent. It's next to. The hypotenuse is always just the hypotenuse. So adjacent and hypotenuse is cosine. Just the normal old cosine because I'm not finding an angle. The cosine of 35 degrees is equal to adjacent 121 over x. Put that over 1 and cross multiply. 1 times 121 is 121. X times the cosine of 35 is x cosine of 35. We have to divide here to get x by itself. Divide both sides by the cosine of 35 degrees. Put that in the calculator. Make sure you're in degrees. And we see that x is about 147.7. We round to the 10th. Question 4. We're looking for an angle. That means we're going to use the inverse function. We still remember SOHCAHTOA. Let's figure out the ratio. X, our point of reference, right here. 121 is the adjacent. 155 is the hypotenuse. Adjacent and hypotenuse is cosine. But since we're looking for an angle, it'll be the inverse cosine. Normally, I put an angle in right here, but because it's the inverse cosine, I'm putting in a ratio, adjacent over hypotenuse, 121 over 155. And whatever this is going to be the angle we're looking for. It's our x. Plug this into Desmos. Make sure you are in degrees. And you should get about 38.7 degrees. Question 5. Again, we're looking for an angle. That tells us we're going to use the inverse function. SOHCAHTOA. This is the opposite, 126. This is the adjacent. The hypotenuse is right here, but we have nothing there, so it looks like it's an opposite over adjacent, which is tangent. Since we're looking for an angle, though, we're going to do the inverse tangent. We don't put in an angle like normal. We put in a ratio, opposite over adjacent, 126 over 131. Put that in Desmos. It ends up being about 43.9 degrees. Number 10, we have opposite over hypotenuse. SOHCAHTOA. Opposite over hypotenuse would be sine. We're looking for an angle. That means it's going to be the inverse sine. Normally we put an angle right here, but because it's the inverse sine, we put in a ratio, opposite over hypotenuse, 153 over 200. Plug that into Desmos. And it looks like X is about 38.7 degrees. In question 13, the sun is shining in the sky out here somewhere. And it's creating this shadow on the ground right there. What we want is the angle of elevation formed. For finding an angle, we're going to use the inverse function. Looks like we've got opposite over adjacent. Opposite over adjacent is tangent. We're looking for an angle. We use the inverse function. Remember, normally we're going to put an angle there if it's the tangent of an angle or the sine of an angle or the cosine of an angle. But because it's the inverse, we plug a ratio in. 17 over 20, opposite over adjacent. Plug that into Desmos, and that will give you X. Looks like we get about 40.3 feet. In question 17, there's a rocket launch, and somebody's watching it from a great distance away. The angle of elevation formed is 24 degrees. They are about 2 miles from the launch site. That's that distance right there. And we want to find how high the rocket is. Well, our angle is right there. We're looking at opposite over adjacent. SOHCAHTOA. Opposite over adjacent is tangent. We're not looking for an angle. We're not going to use the inverse function. It's going to be the normal tangent of my angle, 24 degrees, is equal to opposite x over adjacent 2. Put that over 1 and cross multiply. X times 1 is x, and then 2 times the tangent of 24. Plug that into Desmos, and that ends up being about 0.89045737. Now you notice I wrote all that out because we're going to convert this to feet. You shouldn't be rounding this yet. Don't round until you get your final answer. Since 1 mile is 5,280 feet, 2 miles would be twice that. 3 miles would be 3 times that. All we do is multiply this by 5,280 to find the distance. And again, don't use a rounded answer to find another answer. So be as accurate as you can here. Multiply that by 5,280. There are a couple of ways you can do that. One, you can store your answer. I called it H for height of the rocket. You can store that in a variable h in Desmos. Just type h equal 2 tangent 24, h equal whatever you want. You can use any variable you want. And then what you're going to do is multiply h times 5,280. Desmos will store the variable until it changes as you go down the list of calculations. So this would be your answer right here. X would be 4,700, and to the nearest whole number, which is what it asked for in this question, this 6 would bump the 1 to a 2, 4,702 feet. The other way you could plug this in Desmos is like this. Take 2 times the tangent of 24. You need to put the 24 in parentheses, otherwise it will make the angle 24 times 5,280, and that's not what the angle is. Put it in parentheses, and then take that decimal, that will be whatever that decimal is, times 5,280. Notice you get the same answer when you round to the nearest whole number, 4,702. Question 23. Two buildings are 33 meters apart. From the top of the taller building, which is 140 meters high, the angle of depression, that's this angle right here, to the shorter building is 28 degrees. What is the height of the shorter building? What we need to find is this length right here. They called X the height of the shorter building. Let's call this one Y. Once we find that distance, Y, all we need to do is subtract it from 140. The 33, the distance between the buildings, is this distance right there on the triangle. And in the triangle, I have opposite over adjacent. SOHCAHTOA. Opposite over adjacent is tangent. We're not finding an angle. This will be the normal tangent. The tangent of the angle, 28 degrees, is equal to y over 33. Put that over 1 and cross multiply. 1 times y is y. 33 times the tangent of 28. And we don't need to plug this in and round it. What we're going to do is take, that's y, we're going to subtract it from 140. Our answer will be 140 minus that y, which is 33 times the tangent of 28. Plug this into Desmos, and that will be the answer. Desmos is telling me that this is to the nearest meter. We're rounding to the nearest whole number. 122. Now I want to point out that this is 122.45. We don't look at the 5. Some students want to grab the 5 and turn this 4 into a 5, but that would be wrong. You don't look at the 5. You only look at the 4. So if I round this to the nearest whole number, it will be 122 meters. Our last example has to do with grade. You've probably seen these signs when you travel. Whenever the road is steep enough to be dangerous, especially to big trucks that their brakes get hot on steep hills, you'll see these signs warning them about the grade. What is grade? You already know what it is. Grade is the same thing as slope. So what's the difference? Grade is a percent. When I say that the grade is 10%, remember that it's 10 over 100. That's what 10% is. 15% would be 15 over 100. 52% would be 52 over 100. And it's slope, which means it's rise over run. The rise is 10 and the run is 100. It could be any unit. It could be rise 10 meters, run 100 meters. Rise 10 feet, run 100 feet. Rise 10 miles, run 100 miles. It will be true in any case. What we want is the angle formed when the grade is 10%. Notice that 10 is the opposite and 100 is the adjacent. And in SOHCAHTOA, opposite over adjacent is tangent. We're looking for an angle. That's going to be the inverse tangent. And we don't plug in an angle, we plug in a ratio of 10 over 100, or you could just say 0.1. And that will be the angle X. Plug that into Desmos. And the angle looks to be to the nearest tenth, 5.7 degrees.